So I did my project on machine learning, data science, deep learning, whatever you want to call it, and how it's starting to change the security industry and how hackers are currently using it and possibly how it could be used for secure coding purposes. So I pretty much did a market survey, and if you look into the PowerPoint presentations, you'll see pretty much an overview of how different people are using machine learning. I'll go over um, some basics about machine learning. But basically, what this project was about is um, building a malware detector. So if you have, good binaries versus bad binaries, can you build software that can detect that on the system? And the reason why I went this route is because a lot of deep learning and machine learning techniques highly depend on the data sets that you're using. So I had to use data sets from what was available on the internet. So a lot of things won't work necessarily if you don't have a good data set. So the common term is garbage in, garbage out. So pretty much the algorithm I use is called support vector machine, and basically I won't go into all the details about support vector machine, but really it's just a technique in supervised learning and in deep learning, machine learning, data science. Um, the difference between supervised learning versus unsupervised learning is that in unsupervised learning there really is no um, labeling of the data sets. So pretty much what the algorithm is doing for you is clustering data, and it gives you an idea of um, what might be happening. So it's up to the human to figure out how to label that data. So in the supervised um, domain, you're pretty much giving um, the algorithm a labeled data set. And what that means is you as a human have to go in and classify what is good software versus bad software in this case. And that's why you see the two folders, benign versus malware, because this is just basically a way to label how um, the algorithm is pretty much going to figure out um, what's software may contain malware that can harm your system and what may be safe software. So the whole point of doing something like this is that if you have a data set um, full of bad programs, you hope that this system is going to be trained in a way that if it sees new malware, hopefully it follows the same pattern that all the other malware followed. So it will predict that, hey, this is bad for your system, so you shouldn't use it. This contains malware. So, and that's what you'll see. And basically, I use the industry standard rock curves, and what rock curves is basically um, saying is how well the system is going to predict malware based on the data set that you give it. So that's always the catch 22. So if you don't give it a good data set, or if it's too general, then you won't get good results. So take it with a grain of salt, but basically, the data sets that I have is programs from the internet that are known to be what people are building data sets for good programs versus bad programs, because a lot of people are getting to this domain. And what I'm going to show is basically a program that's going to predict a rock curve. And again, all a rock curve is basically trying to show you the amount of false positive rates that your system is going to have. So if your system has less positive rates, then you're going to be doing pretty well. I mean, pretty much what that means is the percentage of malware that's successfully detected. So that's what the rock curve is measuring based on the data set that I'm showing here. So if we go over here, and sorry about that. So yeah, you just run it. And this is a part of deep learning. And basically, supervised learning always, well, not always, there's statistical techniques, and then there's neural network approaches. The approach I use is I'm using Python libraries, the standard sklearn, Keras, and these are all libraries that are deep learning algorithms. So what it's doing right now is pretty much going through um, the programs and um, extracting features. So from the labeled data sets. And when it's extracting these features, it's trying to basically build out a way to predict future malware in the future. So if you look at the y-axis, this is the amount of true positive rates, and if you look at uh, the false positive rates, you see that we're doing pretty well. So pretty much what this is saying that we're only going to have a false positive rate for new predictions, meaning that if you get a completely new batch of software, um, you're only going to get a false prediction that this is malware when it isn't, is 1 in every 100. So basically, we're like 99%. Now, there's some caveats to that because I can only train off the data set that I have. So basically, there's this thing called overfitting in data science and machine learning, meaning that if your data set is very specific, so maybe I just have buffer overflows in the software I put in there, then it's not going to detect anything that's not a buffer overflow. So even though it's still maybe malware, so pretty much what my system is doing is um, it may be a little bit of overfitting, but I kind of had to do it this way because there isn't a lot of data sets out there. These things are just being built, and that's a common theme in industry right now for deep learning is that these systems are still being built. Data sets are still being collected. It's big business in collecting data sets. And so pretty much what this is a malware detector based off my data set. And this is just showing the training rates for the data set that I was able to collect. And again, you could look up ROC curves. Basically, ROC curves are industry standard how to predict false positive rates versus true positive rates. And you can see my demo is basically showing that out of 1 out of every 100 programs, well, not programs, but yeah, 99% of the programs based on my data set is going to be accurate, meaning that 99% of the time we're going to accurately predict is this malware or not based on my data set. So in this case, you're still going to need a human to pretty much curate the data. Basically, you're going to need someone to label, say, hey, and it depends on what you're trying to do. If you're just trying to build a system that detects buffer overflows, you're going to need a lot of programs and a lot of examples, a lot of training time. And actually, I know this went quick, but it actually took me a long time to actually get to the point where it could train like this, even though I'm using standard libraries. So it all depends on what you're trying to do. I don't think you're going to be able to build something that's totally flexible and it's going to detect everything. So that's why I say you're still going to need human. It depends on what you do. I mean, I guess you could build something like that, but it would, you would have to have a lot of data and you have to be constantly training. So that's where deep learning comes in. But that's pretty much my demo. I know it wasn't much. See, my computer's frozen now. But just to show like the data sets, these are basically programs off the internet. This is like just standard stuff from internet. Basically, files people have collected that are mundane, and if you look at the malware, these are like backdoors that you can find on the internet that you can just train on. And again, I'm just using standard I'm not going to go through all the code because it will be a lot, but pretty much I'm just using standard Python libraries. And yeah, so I get the training examples. I'm training. I have a certain amount of iterations, and then sorry, my computer is freezing. But basically, I'm using standard approaches, and that involves neural networks. And again, supervised learning, pretty much you have labeled data sets, and you're pretty much training a system to perform in a way that you want. So the algorithm itself figures out the weights and the features by itself. I'm not going in and making code to say, hey, this is malware. I'm just saying, as far as the individual features. So this code that I have and neural networks in general are weighted towards, they've pretty much figured out for themselves. Um, so you just have to label the data set, and if you don't give it good data, then it won't give you good results. Um, so yeah, thank you. If you need the code, you can look on my GitHub page and you can download and run examples yourself.